Alright, so here we go. We've got this is a nice little problem. I'm doing partial derivatives. Uh, we want to find the partial with respect to x and the partial with respect to y. Alright, so we can see here that we have a quotient. X is our variable, y is our constant. Okay, uh, you might want to check out the first video. The first video has examples 1 and 2 in it, example 3, and I'll do a couple more after this one. Alright, so here we've got the partial of z with respect to x. Alright, so here, since we have x in the numerator and x in the denominator, we're going to have to use quotient rule. Alright, so remember the quotient rule, it's the derivative of the numerator. Okay, so what's the derivative of the numerator? Well, the derivative of 3x is 3 plus the derivative of natural log y. Well, what's the derivative of natural log y? 0. Y is a constant. Okay? The natural log of y would be the same thing as if that was a 5. Okay? You have to treat y as a constant. Alright? So there's the derivative of the numerator times the denominator, x squared plus y squared, minus the derivative of the denominator. Well, what's the derivative of the denominator? Well, derivative of x squared is 2x plus, and then what's the derivative of y squared? 0. There's no x in this term. The derivative of a constant is 0. So there's the derivative of the denominator times the numerator, 3x plus natural log y. And that's all over the denominator squared. Alright, so let's just distribute and see if we can't combine some stuff. So this is going to be 3x squared plus 3y squared minus 6x squared minus 2x natural log y over x squared plus y squared squared. Alright, so let's see. That's going to be negative 3x squared plus 3y squared minus 2x natural log y over x squared plus y squared squared. And that would be your answer. Okay, so see, it's not very difficult. All right, let's do the other way. Let's take the partial of z with respect to y. I'm going to erase this and so I can work it up here. All right, so I'm back. I'll pause the video while I erased it. All right, so here we go. The partial of z with respect to y. Well, this time, what do? We keep the, I'm sorry, we treat the x term as a constant. Okay, so we do have a y term in the numerator, we do have a y term in the denominator, so we're going to have to use the quotient rule. Okay, so now I've got the derivative of the numerator, so the derivative of 3x is 0. Remember, x is a constant. 3x is a constant in this problem. So that's 0, and then the derivative of natural log y, well, we know that's 1 over y times the denominator minus the derivative of the denominator. Okay, so the derivative of x squared, remember x is a constant, so that's 0, and then the derivative of y squared, that's 2y, times 3x plus natural log y, and that's all over the denominator squared. That should have been an x. Okay. Alright, so simplifying, let's see what happens. Well, I guess what we can do to start out is we can take this whole thing here. Let me do that in a different color. We can take this whole thing and multiply by y over y. So y times this, well, they cancel, and that will leave me with x squared plus y squared. And then this times y, well, that's going to give me minus 2y squared times 3x plus natural log y over y times x squared plus y squared squared. And so we'll distribute x squared plus y squared minus 6xy squared minus 2y squared natural log y, all over y times x squared plus y squared squared. And then we could combine these terms. You know how to do that already. Minus y squared minus 6x y squared minus minus 2y squared natural log y over y times x squared plus y squared squared. All right, so you can see it's not difficult. Just remember, when you do the partial of x with respect, when you do the partial of z with respect to x, you treat y like you do a number. And when you take the partial of z with respect to y, you treat x like it's a number. Okay, so I hope this video helped. I'm gonna do a couple more. So check those out. Check out the first video with the first two examples. Don't forget to like and subscribe. Thanks.